Welcome to Macroedtech online educational services. We are running a revision series for GATE 2025 in two streams, data science and artificial intelligence and mechanical engineering. In today's short video, we will discuss some more questions related to probability and statistics. So let's start. We will cover entire syllabus in 100 days. Initially, we are solving some questions related to probability and overall syllabus of probability and statistics will be finished in 10 days. In today's short video, we will see what is mutually exclusive events, independent events, total probability, and one question related to Bayes theorem. Let's start with mutually exclusive events. So mutually exclusive events are events that cannot occur simultaneously. Please remember some basic points because sometimes in 1 mark question they asked. So mutually exclusive events are events that cannot occur simultaneously. In other words, if one event occurs, the other cannot. For an example, when you flip a coin, the outcome can either be head or tail, but not both at the same time. In probability theory, if two events A and B are mutually exclusive, the probability of both A and B happening together is zero. Means intersection A intersection B probability will be zero in case of mutually exclusive events. You can see here example, rolling a die. The events rolling a 3 and rolling 5 are mutually exclusive. Why? Because you can't roll both 3 and 5 at the same time with a single roll. Second example, drawing a card from deck. The events drawing a ace and drawing a king are mutually exclusive event because one drawn card cannot be both the ace and king. You can see here one question, drawing a card from a standard deck and getting a jack or a 6. So as we know that total 52 cards in a deck. Since these two events cannot happen at the same time, so these are mutually exclusive event. And in case of mutually exclusive, A intersection B will be 0. So as we know that so this value intersection will be 0. So relation in case of mutually exclusive events is sum of both events. So you can see here getting a jack 4 divided by 52 plus getting a 6 4 divided by 52. We can sum here. So answer is 15.4%. You can see here one more example when we have value of PA, PB and mutually exclusive events. So simply you have to put this relation and this intersection will be 0 and we will get answer. Now this question based on independent event, a die is thrown. If E is the event, the number appearing is a multiple of 3 and F be the event, the number appearing is even. Then find whether E and F are independent. We know that sample space 1, 2, 3, 4, 5, 6. First case, or you can say first event, multiple of 3. So 3 and 6 multiple of 3. 3 and 6. And in second case, even number. So 2, 4, 6 even number in this set. So common or intersection is only 6. You can see here common between E and F event is 6. Now probability of event E 2 by 6 because only 3 and 6 multiple of 3. So this is 1 by 3. Similarly for event F probability is 3 divided by 6 1 by 2 and probability of intersection is 1 by 6 because we have only 6 here. So intersection is product of probability of E and F. So this is an independent event. Now next question is based on total probability. I have 3 bags. Bag 1, bag 2 and bag 3. Bag 1 has 75 red, bag 2 60 red and bag 3 45 red. 25 blue in bag 1, 40 blue in bag 2 and 55 blue in bag 3. Next, I choose one of the bags at random and then pick a marble from chosen bag, also at random. What is the probability that the chosen marble is red? Let's solve this question. Now we have two events R and B. R related to drawn red balls and B for chosen bags. This is already given in question. In a structured manner, we can write probability of R divided by B1 equal to 0.75. Similarly, for bag 2, when red ball drawn from bag 2, 0.60, and in case 3, when red ball drawn from bag 3, 0.45. Now this is very important. We choose our partition as B1, B2, B3. Note that this is a valid partition because firstly the BI are disjoint, only one of them can happen, and secondly one of them can happen means mutually exclusive, and secondly because of their union is the entire sample space as one of the bags will be chosen for sure. Using the law of probability, so overall for first bag multiply by probability of first bag. Now for second bag probability is same, 1 by 3. Now put all values, we will get answer. Now one more question. A person has undertaken a construction job. The probabilities are 0.65 that there will be strike, 0.80 that the construction job will be completed on time if there is no strike, and point 32 that the construction job will be completed on time if there is a strike. Determine the probability that the construction job will be completed on time. Let A be the event that construction job will be completed on time, and we have to find out. And B be the event that there will be a strike, when no strike, probability 0.35. Also we have construction job will be completed on time if there is no strike, and 0.32 that the construction job will be completed on time when construction job completed on time with strike is 0.32, because B is the probability of strike and A is an event of completion of job. So 0.32 in case of strike and completion of job. Similarly, when no strike and completion of job is 0.80. Now since events B and B dash form a partition of sample space, suppose we have sample space and all are parts, so we will use total probability. And without strike, so after putting all values, we will get 0.488. This is our answer. Now one example to understand the Bayes theorem. Bag 1 contains 3 red and 4 black. We have bag 1 contains 3 red and 4 black. Bag 2 contains 5 red and 6 black. Now one ball is drawn at random from one of the bags and it is found to be red. This is final that ball is red. So find the probability that it was drawn from bag 2. So this is the condition. Find the probability that it was drawn from bag 2. So let E1 be the event of choosing the bag 1 and E2 be the event of choosing bag 2. Same probability 1 by 2, and A be the event of drawing a red ball. Now understand. Total ball in first bag is 7 and in second bag 11 ball. So when red ball drawn from bag 1, probability 3 by 7, you can write here. Now second case, when we drawn from second bag, and there is 5 ball, 5 by 11. Now the probability of drawing a ball from bag 2 being given, that is red, that is given. So by using Bayes theorem, please remember this formula. Because A is already given. Event of drawing a red ball is already given, that drawn from bag 2. So we have to be find the probability of drawing ball which comes from bag 2 and it is red is already given. So you can apply here formula, and after putting all values we will get answer. So this is denominator is a total probability. Thanks for watching. Please subscribe our channel for daily updates.